Okay, acid, bases, and salts. So we have the three types. One is the acid, we have the neutral, and then comes the bases. Okay, so these are the three types of what we see. So we can bifurcate using the pH value of any component by the three types. One is the acids, the other is the neutral, and the third one is the bases. So usually the sour items will be acids in nature. Which are sour in nature, right? They are acids in nature, most of them. Okay. And we have natural acids. We will have in some components, we can see the natural acids. Like in lemon, we have the citric acid. A lemon, it is having the citric acid. Then we have tamarind, we have the tartaric acid in it. Okay, because of that, it is sour in nature. Okay. Then we have vinegar, correct? So vinegar contains the acetic acid. It contains acetic acid. Okay. Then what we have, oranges also, it is citric acid. They call it as citrus fruits, correct? Orange, lemon, kiwi, all this, they call it as citrus fruits. Why they are called as citrus fruits? Because they contain the citric acid in it. Okay, so they are called as the citrus fruits. Then we have curds, right? Curds, it contains lactic acid, which helps in the digestion. Okay, so we get acids in many natural compounds also. They are usually mild acids in nature. They are usually mild acids in nature. Then comes the bases. Bases are the one. Okay, say bitter in taste. Bases mostly they will be bitter in taste. One of the example is sodium hydroxide. That is, we use baking soda, right? So that is also a base in nature. And neutral example is the water. Water is neutral in nature. Okay, water is neutral in nature. Whatever we consume, right? All will be either like neutral or mild acids or mild bases. Acids and bases will be there, but they are mild in nature. Okay, so strong acids and strong bases, we find that. Okay, we have the like strong acids and strong bases, but we usually don't find in the natural components, but and also they are very strong, so it is not consumable. It is not consumable. Okay. So acids, which are example, hydrochloric acid we have, sulfuric acid we have. They are strong acids. They are also called as mineral acids. Mineral acids means it is a man-made acids. So most of the man-made acids, they are strong acids, whereas the natural one which we get from the fruits, all these, they are mild acids. Okay, and what is the basic difference between acid and a base? How, like, why we call any component or a compound as an acid? pH value. Yeah, that is the one way to find. Correct. pH value. If the pH value is less than 7, then it is an acid. Okay. So if a pH it is less than 7. Okay, if it is less than 7, then less than 7, it is an acid. Okay, we call that as acid. Okay, pH, it is the, what do you call it? It is H is hydrogen, produced hydrogen or something, it's there. That is the meaning. Okay. Or production, some P meaning something is that produce hydrogen or something is that is the meaning. Okay, I will tell you how it comes. Wait, less than 7, it is an acid. Okay, when pH equal to 7, it is the neutral in nature, and pH it is greater than 7. Okay, it is greater than 7. It is a base. Okay, it is a base. So, and 7 is there, right? When the pH value keeps on decreasing than 7, it becomes a strong acid. And if pH increases than 7, as increases more, it becomes strong base. For example, you have 6, 5, 4, 3, 2 like this. 6 is a mild acid. Okay, whereas 4 is a strong acid. That means as the pH decreases, its acidic value increases. Okay, and as the pH increases, okay, here the base increases. That is, 10 is a mild base, 12 is a strong base. That's how it is included. Okay. Again, I repeat, right? See, 7 means the pH value is 7. That is neutral in nature. When pH is less than 7, it's an acid. pH greater than 7, it is a base. Okay. So pH, as it goes on decreasing, the acidic value of that component increases. So any component having pH 6, it's mild acid. And compared to pH 4, if that component is having pH 4, then it's a stronger acid. Okay, but in this side, it's the opposite way. So when it going from 7, usually we take until 14 like that. So if the pH is 10, it's a mild base. If pH is 12, then it's a strong base, like that. Okay. And water is neutral in nature. That is why if you drink water, no, you will not get heat or cold because of that. If you drink cold drinks, ice cream, there you will, that may vary. They will tell no, when you eat the ice cream, at that moment you feel cool, but actually it increases the heat of the body, like that, and all they will tell. But with the water, okay, the body will not get too much heat or too much cold like that. Okay, why? Because it is neutral in nature, and it is better to consume in the like 6.5 to 7.5 or 8 like that. That means it should be neither the too much base nor it should be too acidic. Whatever we consume, most of the time it is neither too acidic, neither too base. Okay. Whatever we are seeing, these natural sources of acid like orange, lemon, tamarind, all these are acids in nature, less than 7 only. But they are mild acids. Okay. That is why it is consumable. Whereas we consider the other different types of acids like hydrochloric acid, sulfuric acid, all these, they are very strong acids. So it is not consumable. Okay. And most of the strong acids are mineral acids. Mineral acids, it is man-made acids. They call it as mineral acids or synthetic acids. Okay, so they are very strong in nature, whereas these things like vinegar, orange, lemon, tamarind, tomato. Tomato has what acid? Oxalic acid. It contains the oxalic acid. Huh? No, tomato also contains oxalic acid. Okay, so like this, vinegar contains acetic acid, tamarind contains tartaric acid, citrus fruits contain citric acid. Okay, all this actually helps for digestion also. Okay, but they are mild acids. And then the base, if you consider the baking soda, it's an acid which you can consume actually. Okay, like this. Whereas the potassium hydroxide, all these, they are strong acid, if you consider. Okay, and strong acids or strong bases, they are corrosive in nature. Okay, they are corrosive in nature. Corrosive means if you put on anything, it starts itching it out, like that, they'll say, right? So that is corrosive in nature. Okay, it is about that. And tell me how you can say, or pH, how it becomes less than 7 or more than 7, or how what is the characteristic, because of that we can say it's an acid. Very good. It produces the hydrogen ions. Whenever any compound, if it is mixed in the water, if it produces hydrogen ions, then it is an acid. Okay. For example, hydrochloric acid. Okay. You people can see now, well? Okay. Hydrochloric acid, when you dissolve in the water, it becomes H plus and Cl minus ions. Okay, H plus and Cl minus ions. So measure of H plus ions, that is only the pH value. Okay. So measure of that hydrogen ions, that is only the pH value. That is why it's called possible hydrogen or production hydrogen, something meaning is this. Huh? Even potential. Okay, that is it. That's it. Okay, so it is how much the hydrogen is produced. Okay, so measure of that is only the pH value. Okay, like that. So H plus and Cl minus. If hydrogen ions are more, you will get pH value less. How it comes, I will explain another day. How it will come less. Okay. So pH value will be less. So how much hydrogen ions will be produced depending upon the, we will say how much it is acidic. If it is producing more hydrogen, then it is more acidic in nature. Okay. That is the main how we bifurcate the acids. What about the bases? How you can say anything as a base? That is the one thing. Other than that, OH minus ions. If it is producing the OH minus ions, example NaOH, you will get Na plus OH minus ions. How much OH ions are produced? Depending on that, we say whether how much it is basic in nature. Okay. So how much OH minus ions are there? Depending on that, we say how much it is basic in nature. This is how we bifurcate. That is the actual way how to know whether it's an acid or a base. Okay. So acid means when that compound is dissolved in the water, we get hydrogen ions. How much hydrogen ions are produced? Depending on that, we say how much it is acidic in nature. And base is how we can know it is OH minus ions. It's a measure of OH minus ions. How much OH minus ions are produced in the water when it is dissolved in the water? How much OH minus ions are produced? Depending on that, we say where how much basic in nature. Okay. Huh. Yeah. See, lactic acid present in the produced in the muscles will cause the pain. But lactic acid, it is a mild acid which is helpful for the digestion of the food. Okay. Curds. It's present in the curds. Usually, actually, it is like they say it's probiotic, no? Curds. When you eat, and usually they say vegetarians, usually at the end you have to eat some curds, they say, right? Curds or curd rice. Why they say? Because it's a probiotic. Okay. They help in the digestion. Okay. But when it is in the legs, it produces pain like that. And everything is like that. In how much quantity it is there, in what form it is there, where it is used. Depending on that only, it will change too much. See, iron tablets we take, right? It contains the iron. But directly iron you can't consume. So it should be consumed, right? No, it should be consumed in a form which body can take. That is the key thing. The content which body can take, which can digest, that is the key thing. Nowadays they say, protein powder and all. They contain the proteins, but that cannot be absorbed by the body properly. Okay, and it causes problem in the kidney and all if you use for a longer time. They say actually protein powders and all what we get, Why? Because even though it contains the proteins, the form it is made, which form the body can accept, all these will matter a lot. Like that. Okay. So understand now what is the basic meaning of acid and the base. H plus ions is produced in the water. So that H plus ions measure gives you the how much acidic in nature. Whereas how much OH minus ions are produced, that measure gives you how much basic in nature. Okay. It is acids. Acids are those substances which have sour in taste. Which have a sour taste. Okay. They have the sour taste. Acids change the blue litmus paper to red. Okay. Acids produce H plus ions when dissolved in water. When dissolved in water. Okay. There are two types of acids. There are two types of acids. First one is the natural acids. Natural acids. Acids which are found in natural components or compounds. Natural compounds. Okay. Next one is the mineral acids. What is that? People are busily talking. Mineral acids. Acids which are man-made. Acids which are man-made, are called mineral acids. Mineral acids. Natural source. And this is acid. Okay, first one, vinegar. Okay, so it is acetic acid. It contains acetic acid. Then orange or lemon, they contain citric acid. What is that? Why you people are talking? Tamarind, tell me what type of acid is there? Huh? Tartaric acid. Write down tartaric acid. Okay. Next. Tell me tomato. What does it contains? Oxalic acid. Curds. Yeah. Curds contains the lactic acid. Okay. Then and sting. See, and it is very small, right? When it bites, but it hurts. When you consider it is really very small. Why it hurts? Because when it stings, okay, it will produce some acid. It will inject some acid. That is why ant sting or honeybee, even though they are very small, wherever it bites, it hurts actually. We see the swelling, everything, right? Because of that. And sting. It contains methanoic acid. Huh? Yeah, that's why we put baking soda so that it neutralizes. Huh. But it should be mild. That base only should not be corrosive in nature. Skin burns. Huh? Huh. It's a base. It should, yeah, you can use, but make sure it is mild in nature. Because that itself should not burn the skin like that. Okay. So vinegar, all these they will ask in 1 mark question sometimes. So what are the acids we have? And sting, it is the methanoic acid. Okay. Some examples of mineral acid. Can you tell me mineral acids? Hydrochloric acid. Yeah. Sulfuric acid. All these are the HNO3, nitric acid. All these will come to mineral acids. So mineral acids are the one which is produced, okay, which is produced by man. That is a man-made acids, and usually they are very strong acids. They are the strong acids. Okay. Next, write about the pH. pH, it's a number which indicates, it's a number which indicates the acidic or basic nature of the solution, or basic nature of the solution. Okay, first one, if pH is greater than 7, it's greater than 7, it's a base, correct. It's a base solution. pH less than 7 or pH equal to 7, what is that? It is neutral. Neutral. Okay, if pH is less than 7, it is, solution is acidic. Solution is acidic. Okay. And all the organisms also in the body, like the pH will be usually near to the neutral. In our blood also, it should be within the range of 6.5 to 7.5. In the small range, that range only it should be there. If the pH of any organism drastically varies, the person or any organism will die. Okay, it should be in that range also. Near to the neutral, it will be changes in some body or something. If they eat poisonous thing, maybe pH may vary. Then only it will, simply like that it will not vary. Okay. Yeah, that is produced. Why it is produced? Because to kill the germs. It is very acidic. That is why it can kill the germs in the food. Yeah, there also it is produced. And in man-made, it's actually not man-made. Whenever hydrochloric acid required in the outside world, then it is produced like that. Yeah, see one thing, whatever we don't know anything, that we cannot do in the real life, I'm telling. bird can fly. That is why by seeing that we know that we can make the aeroplane. Anything which we don't know at all, we cannot innovate that. Understood? No. Whenever we are not getting that, maybe we try to produce, replicate that. Anything we don't know at all, still now we cannot do. That is one of the limitations of the math. Okay, and who do the scientists also, if you ask, they learn from the nature and they try to do the things. We don't know at all what we can do. We don't know that, how you can, right? Whatever we know from the learn from the nature, from that only we try to do the things. Okay. So hydrochloric acid, yes, it is produced by the stomach. Why it is produced? When it is mixed with the food, first thing it can kill the germs. I told you, right? Very too much acidic also, it's not good. So that is why it can kill the germs. And mucus is produced around in the stomach so that it will not affect the lining. And the another one, whenever it's mixed with the food it becomes little bit mild because when food is not so much acidic, correct? Usually it will be alkaline. When it is mixed with the acid, so what happens? Less acidic when compared. Alkaline or base, same thing. Okay, so it becomes mild, little bit mild. Okay, that is why, since it's a strong acid, that is why that mucus is also produced in the stomach. Okay, mucus is also produced in the stomach, so that it will not affect the stomach. But still, if too much of hydrochloric acid is produced, they tell no. For a long time, if it happens, that ulcers, all these will happen in the stomach. What is the reason? It will affect the stomach, like that. Okay, and one thing, whatever we don't know at all, we cannot do that. Whatever we know in the nature, that only we try to replicate. Whatever we read, the physics or chemistry. That you have to search. Okay, like that. Understood, no? Or maybe combination of the things only we can make. Whatever we don't know at all, we can make. That is not true. That can't happen. Okay, right? Next. Next about the indicators. Write down indicators. Indicators are the substances. Indicators are the substances that change their color, or odor when added into an acid or alkaline solution. Alkaline means it's a base or alkaline solution. So in indicator, we have two types. First one is the natural indicators. Natural indicators. These indicators are found, okay, they are found in nature, in the plants, okay, in the plants. Example, first one is the litmus paper. Litmus. Okay, first one is the litmus. Okay, natural, see, indicators. Is it natural? Yeah. Litmus is a solution what we get from the plant. That they put it on the paper so that it gets. Because of its quality. Why you are like this? Shiver. That's how in the nature. Yeah, wait. So indicators, first thing, indicators, there are two types. One natural indicators, other is the artificial indicators. Natural indicators means that we directly get from the nature. That we call it as natural indicators. Okay. So what does these indicators do? Indicators, they change their color or the odor when with the acidic and the basic mediums. Okay. First, one example, if you consider litmus paper, when you dip a litmus paper in an acidic medium, that is, when you dip a blue litmus paper in an acidic medium, it changes its color to blue, red. Sorry, it changes its color to red. Okay. So there we will know it is an acidic medium. There we will know it's an acidic medium. Another one, red litmus paper. Red litmus paper, if you dip that in a base, it changes its color to blue. So there you will know it's a what type of solution? It's a base. Okay. If I dip the red litmus paper in an acid, what happens? No change will be there. And the litmus, how you will get? We get the litmus liquid from the plant extract. From the plant extract. Okay. Okay. Then
Actually, get rid
it's a liquid. What we get from the plant extract, that they put it on the paper. Maybe with some procedure they do that. Okay. So then it becomes a litmus paper. Nothing. There will be no change.
Then if you put it for red litmus paper and you don't know if it's acid or basic, you only know that it's not basic. You don't know if it's neutralized.
Correct. You will not know.
So if you look for red acid.
Yeah. If you have only red, correct. You will not know.
It changed to acid and neutralized.
So every one is the same.
Maybe hard to declare. Apparently there was a question that came in board exam that there was an acidic region and basic and they had fully recognized. So that identify also. The first they had to dip it in base and became red. Yes, it became blue and they changed the they put the red into the base.
You require actually, so if you have neutral, you should have the both. Then only you will be able to find it.
Exactly, they had red. It's red, basically blue. Then they checked it in acid and neutral. They did not know what it was. Then it became red again. So we came to know what is acid and what is this. They have only red litmus.
If you have one litmus, you have three solutions. And one of the solutions is acidic, otherwise it's you don't know which is acidic.
Wait. You are confusing. Wait. Let me.
It is acidic. Which one?
Okay, which litmus color?
You have it in red.
Okay. So then you add, you put the red in this. It turns
How you
blue.
know?
So but I all three. Then one will become blue. So you know that is this. So then you put the blue in one. One will turn red. That is the answer. It won't get anything in middle. You can. So that's what you do basically. It is the board exam
Because of board exam.
Red litmus will turn into blue. Correct.
Then you check the other one is acid or you put it in both. Which turns red again. Because that is acid. That is one is base and one is neutral. That is the
Okay. Next. Tell me other natural indicators now.
Turmeric powder.
Turmeric powder. What happens? Turmeric powder. Turmeric powder.
red in
Base. It will change its color. It will change its color to reddish brown in the base.
the acid it does not change.
With the acid, it will not change its color. Not even with the neutral. Okay. This is about the thing. Next about red cabbage juice. What happens?
But
It does not change with the acid. With the base, it changes its color. Okay, most of the, many, not the most, many will not change their color with the acid. It will change their color only with the bases. Many, not the all. Okay. Then we have the man-made indicators. Okay, man-made indicators. One is the methyl orange, another one is the phenolphthalein. Okay, one is the methyl orange, another one is the phenolphthalein. Why they are called as synthetic indicators or man-made indicators? Because it is produced in the lab. Okay, it is produced in the lab. That is why they are called as the synthetic indicators. Okay, write down this. Another one, we have olfactory indicators. Olfactory indicators means by change of the smell, we will be able to identify. Okay, then we use the olfactory indicators. Okay, then we use the olfactory indicators. Onion, vanilla, all these are the examples of olfactory indicators. Which one? No, most of the time it will be natural. Onions. Yeah, it changes its smell. Vanilla, if you take the bean, right, it will have a very good smell, a strong smell. So when you put an acid, it will not change its smell. But if you put a base, that smell will be lost. Even with the onion, the same way. Okay. So because of that, we can say olfactory indicators. Where we know by its change in the odor. So they are called as olfactory indicators. Okay. Write down now. Next answer, one is this. Don't make sound or someone come and sit here. Next time you disturb, you become. Okay. Okay, next time you people are sitting park. And every day you will be in the same way. Okay. Write down now. First one, second one. It is the red cabbage juice. Red cabbage juice. So whenever when you put an acid, what happens? There will be no change in color. It will be red itself. No change in color. So that will be red color only. It will be there. Okay. Whereas when you put a base, it changes its color to red. Red will change its to green. Write down that. Okay. So indicators are the one that change their color or the odor. Okay, when you consider, you have two types. One is the natural indicators, other is the man-made indicators. So natural indicators, which we get directly from the nature, that is from the plants. So one is the litmus paper, what we use. The other one, red cabbage juice. Red cabbage, what we get, right? If you take the juice of that, okay. And when you put some drops of acid into it, there will be no change in the color. It will be red itself. But when you put the base, it changes its color to green. It changes its color to green color. Okay. Then, everyone. Then about the turmeric, tell me once. Reddish brown color, correct. There will be no change in the color. Turmeric, correct. So third one is the turmeric. Turmeric. juice. Okay. So with the acid, it will be yellow itself. It will not changes its color. Whereas with the base, it changes its color to reddish brown. Okay. It will change its color to reddish brown. Next comes the synthetic indicators. Write down this. When you consider to synthetic indicators, we have phenolphthalein and the methyl. Okay, phenolphthalein, it is colorless in nature. It is colorless in nature, but with the base, it changes to pink color. It changes its color to pink in color. Okay, that color exactly depends on what pH value we put. Okay, it may be a pink, purplish pink, all this, it depends on how much is its pH value, strong the base is. So depending on that nature. Okay. Next comes the methyl orange. As the name itself, it is orange in color. Okay. It is the orange in color. So whenever you put that to a neutral, there will be no change in color. It will be orange. But when you put to the base, what happens? It becomes yellow in color. But with the acid, it changes to red. Again, I repeat, methyl orange, it is a man-made indicator or a synthetic indicator. Okay, it will be orange in color. With the neutral, it will be orange. Okay, if you put some acid to it, it changes to red. But if you put some base to it, it changes to yellow color. Okay, so methyl orange, it is actually it's one of the best indicators because it will change. It will have different colors with the base and the acid. Okay, it is one of the best indicators because it will tell you like acidic one color, base one color, and with the neutral it will be different. No, it will be colorless itself. Okay. So sometimes they ask in one time that asked in the board exam, which is the best indicator, it is the methyl orange. Because that also will change, but with the base. No. Most of the natural indicators they don't change with the acid. They change their color with the base. So then what happens? We'll not know whether that one is an acid or a neutral. Okay, but with the methyl orange, it is easier to find all the secret. Okay. Natural is a litmus paper. Okay, it is a litmus paper. And there is something called universal indicators will be there. Okay, universal indicator, yeah, that it is also produced in the lab. Okay, universal indicators. So what they do, for example, when you want to find the pH of something and go in there, they use this universal indicators where it is made by combining many different solutions. They do that. Okay. So, if, for different pH value, actually, we will get different shades of color there. From depending on that, exactly what is its pH, they will be able to identify. Okay, so they will have the earlier with the for the skin tone they used to show some chart or something, a small strip like the shade of the skin will change. That in some advertisement, Garnier or something, they used to see that strip, right? Similar way, they used to see, I think. Like that only here, they will have different shade for each, they will have that strip. Okay, for different shades, whatever they get, they will know what is the different pH value. So if you use the universal indicator, by like if you put some acid or a base for that indicator, it will change its color. And depending on its pH value, okay, if it is a strong red color, maybe it's a strong acid, like that. The color shades will differ. From that, they will be able to identify the correct pH of that. Okay, they will be able to identify the correct pH of that. Right now. Synthetic indicators. Hmm. Write down now. You only write. Let me see phenolphthalein. What you will get. Like start writing. Right. Good. Okay. Good. Phenolphthalein. Phenolphthalein. So color in acidic. What will be the color in acidic?
Colorless.
Colorless. Good. It is colorless. Okay. It is colorless. Okay. Whereas in basic solution, it is pink. Okay. In neutral solution, it is colorless. It is colorless. Okay. Next comes the methyl orange. Methyl orange. So, what is the original color of this methyl orange? It is orange. So, with the neutral, it will be orange in nature. With the acid, it will be red, and with the base, it will be yellow. Okay. And then comes the olfactory indicators. Those substances whose odor changes, whose odor changes, okay, whose odor changes in acidic or basic medium, in acidic or basic medium, are called olfactory indicators, are called olfactory indicators. Olfactory indicators. First one is the vanilla, second one you write it as on. Yeah, two indicators you can write. Okay. First, we can write it. First example, it is vanilla. So it has a strong smell, right? So when you put an acid, there will be no change, but when you put a base, it will that smell will be lost. By that you will know that it is basic in nature. But acidic and neutral, it is difficult to identify. First one is the vanilla, second one is the onion. Just write the explanation for that. Whenever you add an acid to the vanilla, the smell will not change. With the base, the smell will be lost. Even for the onion, it's the same. Whatever we use the salt, common salt, what we use, no, that is also it's neutral salt. What you use? What is that salt? Is sodium chloride is the salt what we use. That is also neutral salt what we use. Its pH is 7. Okay. So most of them, which is edible, either it's mild acid, it's neutral, or the mild bases in nature. Okay. So universal indicators, they produce differentiates a different concentration of H plus ions in the component of the compound. Okay. More will continue with that. The indicators. So read and come once I ask about acids and bases questions, then we will continue. Okay. Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.